Hello. This lesson is going to be an introduction to the concept of sets. Now, sets is a very broad term that covers a lot of different things. In this lesson, we're going to keep it to the Algebra 1, Algebra 2 level. You could even do this maybe in a pre-algebra class. The algebra content is not advanced, and I'm just really trying to focus on the pieces of sets and set theory that can ground your algebra skills a little bit more. As always, give this video a thumbs up if you find it helpful, subscribe to the channel for more math content, and drop me a comment or a question below to engage. We're going to start with the question, what are sets? So we want some kind of working definition of what a set is. And if you think about it for a moment, you might be able to think of some examples of sets. So maybe in your home, you have a set of tools or a set of screwdrivers. I'm recording this in a room where I have a set of dumbbells. Typically, we think of a set as some kind of a collection. And that's a good place to start with a definition. A set is a collection of, now I have this advanced vocab here, a collection of things. I put it in quotation marks because it's not like a great word to put in a definition, but it could be a lot of things. Now, the examples I just gave were all physical objects. So like a set of screwdrivers, and you could lay them all out, or I could like put all my dumbbells on the floor. I won't do that, but a set of things, but it's not limited to objects. Okay, so I wanted a broader word than objects. In math, we usually mean a collection of numbers. Okay, so we talk about a set of numbers, but we're not limited to that. We could also see collections of shapes or other math entities at higher levels. So it can get really abstract. Now, for an algebra class, we're going to focus on a collection of numbers because that's relevant to algebra. But if you were in a geometry class, you could talk about sets of shapes, okay? And you could talk about subshapes of parallelograms or quadrilaterals or things like that. Now, the symbol for sets. So when you're talking about sets, this is where you use what I call like the squiggly brackets. All right, they look a little bit like that. That's about as good as you're going to see me do them. More often than not, they end up kind of looking like that. When I was a student, I never liked to do the squiggly brackets because I didn't feel like I could do them very well. I still can't do them very well. They do not need to be perfect, okay, when you're making your own set symbols, but what you can't have them looking like is parentheses. Okay, so no on parentheses, no on brackets. They do have to look a little squiggly. Okay, so that's our symbol for sets. When you see that, you know you're dealing with a set of stuff. And there's a lot of other notation that comes along with sets. So there's a really specific vocabulary and way of talking that we talk about when we're talking about sets. We won't get into that too much now. The items in a set are either called members, so we call them the members of a set, or the elements of a set. And I think I tend to use the word element. So like 2 is an element of the even numbers, okay? Or 5 is an element of the prime numbers, something like that. But members is also a common word to be used. So members or elements in the set. So there are actually probably 3 main operations that you can carry out on sets, but we're just going to talk about 2 of the main operations, and those are union and intersection. Okay, those are 2 things you can do with sets. And we'll start with union. Union is the joining of 2 sets into one. And I remember somebody at some point when I was studying sets said it's like a marriage, the union of 2 families. So you have 2 people and you have this union, and now the 2 families become like one big family. But that's essentially what union is. Okay, it's the joining of 2 sets into one. You do not duplicate items. So if you ever have a situation where you see a number in a set, you should never write it more than once, okay? And I've used the illustration of the set of students in my classroom, that there's only one of a student, like there's only one of you. And even if your name appears on more than one list, there's still only one of you. So you don't get listed, you don't get put into the classroom twice. So we never duplicate items. I'll show you what I mean when we do an example. And the symbol for union is this, which is usually fairly easy to remember because it looks like a U. So U for union, looks like U, union. That's how I remember it. The union looks like U. All right, and here's an example. So this is my first set. So my first set is the numbers 1, 2, and 3. And my second set is the numbers 2, 4, and 6. And then the operator is between them. And so this tells me what I'm going to do to the two sets. So remember that union is the joining of two sets into one set. So I'm going to open up my set and I'm going to do 1, 2, 3. Now I'm going to come over here and add this other set to it. Now, notice that the number 2 is in both sets. This is what I mean by don't duplicate, okay? If your name appears on 2 class lists, okay? I got the class list of students in group 1 and overall class, I don't know. Name is on 2 places. There's only one of you. Okay, only one of you. So you only get listed in the set once. So I'm not going to relist the 2, but I am going to combine or add in the 4 and the 6. So the union of these two sets is 1, 2, 3, 4, 6. Just you do not duplicate the 2. Now, most of the time for convenience, we try to list the numbers in ascending order, meaning from least to greatest, but you don't have to list them in ascending order. So if I were to ask you to do the union of these two sets and you did 1, 2, 3, 4, or sorry, 1, 2, 4, 6, 3, that is also a correct answer. So there's nothing ordered about the set. It's not like our XY pairs that are called ordered pairs where the order matters. Sets are not ordered. You can list the numbers or elements in any order that you want. Think of that as being like, again, the set of students in a classroom. You can change the seating arrangement. You can shuffle the order of the names on a list, and it doesn't change who is in the class. It would still be the same set of people, even if you changed their arrangement. So this is just like changing the seating arrangement in a class. Different seating arrangement, same class. Years and years and years ago, I was teaching a class for a graduate. I was a graduate student, and I was teaching a class, and I had a undergraduate aide that would grade homework for me, and the aide was just working from an answer key, and the answer key listed all the answers in ascending order, and that person went through and marked everybody wrong who shuffled up the order, which meant that I had to go back over all the homework and regrade it. So, but we do tend to put them in ascending order for convenience. All right, the other operation is something called intersection. And intersection is the overlap between two sets. So you can think about like the intersection of two roads. Okay, so you've got one road, like we'll call this like the green road. Okay, there's the green road. And then you have the blue road. And the intersection would be right there, and it's where the two roads overlap. It's where the two roads come together. Well, it's the same deal with intersection of sets. It's where the two sets overlap. Now, the symbol for intersection is, you can probably figure it out because it's up on the screen there, is this. It's like a union symbol, but it's flipped over. Now, I don't have a great way of remembering that. So what I do is I just remember that symbol is union. So U for union, and that must be the other one. Okay, which must be intersection because that's the only other thing it could be. So union and the other one, which is intersection. So looking at this example, so these are the same two sets. We're looking for what is in both sets or where are they overlapped. Well, I look at the 1, okay, and I look over here and there's no 1, so that's not in the intersection. Look at the 2, aha, the 2 is an overlap. 3 is nope, no 3. And then I actually don't need to check any of the others because I've exhausted the first set there. So, could you go over and check the 4 and the 6? Yeah, sure, but you already went through everything that was in set 1. So, and 4 and 6 weren't there. So the way you would write that is you'd write your set symbol and you just put the number 2 in it. So the intersection of those two sets is 2. Now, a set with nothing in it is called the empty set. And you might say, well, what do you mean, like a set with nothing in it? Like, how could that be the case? I will give you an example of a set with nothing in it. Put this down here. Now, there's a couple symbols for the empty set. The first one is super intuitive. It's set brackets with nothing in between them. So that will work. That is a symbol for empty set. One that you might see a little bit more often is that symbol there. It's like a 0 with a vertical line through it. Okay, it means the empty set. So here's an example of an empty set. We could have the set of all positive numbers, and we're going to intersect that with the set of all negative numbers. Okay, and you think, okay, well, the figures are all the positive numbers in that first set there, and then all the negative numbers, and you're looking for the overlap. Well, where's the overlap between the positive and negative numbers? Well, there isn't any. And so you would say, well, the answer to that is the empty set. Okay, there's just nothing in that set. There's nothing in the intersection. Right. Now, you may see operations represented with Venn diagrams, and I don't even know when you might encounter this. It turns up maybe in like probability statistics, that kind of thing. So we're going to look at these two sets represented on a Venn diagram. And what we do is instead of having these brackets, okay, so instead of having the brackets around them, what we do is we have like gigantic circles. I don't know if they're gigantic, but circles, okay? And in this first circle would go all of the numbers from the first set. In the second circle would go all of the numbers from the second set. And then this region right here where the circles overlap, that's where you would put any elements that were in both of the sets. So looking at the first set, the number 1 is in the first set, but not the second set. So I'll go ahead and put the 1 there. 2, though, is in both of them. So I'm going to locate the 2 right there because remember, we don't duplicate numbers. So you don't want to put a 2 in there multiple times, but you do have to make sure it gets in both of the circles. 3 is also present in both, and 4 is in the first one, but not the second one. Coming over here, -1 is in the second set, but is not in the first set. 0 is in the second set, but not in the first set. And then the 2 and the 3, we already have on there. And so that's another way of representing it. And it's usually very useful. It's very, very visual. And you can see, okay, this is my first set. This is my second set. And when I taught a topics in math class, I would give students Venn diagrams and ask them to interpret them, like tell me what is all the things in like set A or set B or in the intersection and overlap and that sort of thing. So union. Okay, so I'm going to swap the color and do union. So what would the union look like? Well, the union would look something like this. The union would be represented by the entire set. So it's the merging of both of them together. And again, you do not duplicate the numbers, okay? And if you were asked to list it out, you'd probably go find the smallest number and then try to list them in ascending order, or maybe not. Maybe you're just going to go from right to left and say, I don't have to put them in order, so I'm not going to. The intersection is the region of overlap. So the intersection is just that chunk right there. Okay, and so the union would be the entire thing, and the intersection would just be the region of overlap. Now, what more is there? Well, like lots. Okay, this was super basic. Here's what a set is. Here's some symbols, notation, how we can represent them. Okay, like that's all we're covering. We're going to cover one more thing, in this lesson, but there is lots more that you can do. You can deal with Venn diagrams that have 3 things. You can use Venn diagrams to analyze data, survey results, just lots of stuff. We could do an entire unit on sets, their operations. The other operation is something called taking the complement, and that involves talking about something called a universal set. You can do different representations of sets, notations that are used, and applications. Okay, like I could put together a whole video series on sets. Okay, and that's the only thing that we would cover. Set concepts turn up in places, so they turn up in logic. If you ever get the opportunity to study logic, you're going to mimic a lot of your set ideas with ands and ors. I teach an electronics class that also duplicates logic. We do a lot of logic in that electronics class, but we are able to design circuitry that are based on things like union and intersection and other surprising and interesting fields. So they do come up in a lot of places. They really do. We will cover one more idea that relates specifically to the study of algebra. Okay. And this is just giving you a taste of it. So the next time around, when you see or hear something that has to do with sets, you'll have a little bit of a foundation. You're not going to be coming at it like cold with no background. Now, there's one more idea that really relates specifically to the study of algebra. And this gets into the idea of a relation. And I know for me, a lot of times I will jump in, especially in my Algebra 2 classes, will jump in at the definition of a relation. But in order to adequately define a relation, we need to talk about sets first. So a relation is a mapping between 2 sets of numbers. That is what a relation is. And so if you throw that definition out there without actually talking about what a set is first, it's not that you can't wrap your head around it, but it does end up being a little bit abstract. So the first set where the mapping originates is usually named X, and the second set where the mapping lands is usually called Y. Now, there are other vocabulary words for these sets, but we're going to save those for a future lesson. We're not going to complicate the set stuff with more vocabulary that goes with it. We'll cover it eventually. So here's an example. Okay, so my first set of numbers, which is called like set X, we're just going to call that set X, is 1, 2, 3. The second set of numbers is 4, 5, 6, and we're calling that set Y. So we have set X and set Y. And a mapping is something like this. You take the 1 and you map it over to the 5. And again, the X's is where the mapping originates and the Y is where the mapping ends. And then maybe we'll take the 2 and we'll map the 2 to the 4. And maybe we'll take the 3 and map the 3 over here to an X. And we will represent the mapping with XY ordered pairs, which if you've studied algebra in like at all, you've probably encountered your ordered pairs. So we would look at this, the number 1 mapped over to the number 5. Okay, we just kind of follow the mapping, the number 1 mapped over to the 5. The number 2 mapped to the 4, and the number 3 mapped to the 6. And so that's essentially what we do is we'll take that mapping. So it's taking one set and another set, and you're just relating the 2 sets together. Okay, how are we relating them? Well, with this mapping. Now, is there a pattern to the relation? Usually, yes. Otherwise, it would not be, oh gosh, I have a typo. It would not be, that's important, not be particularly useful to us. Okay, if there's no pattern at all, like we don't really have any real life use for like tons of random numbers floating around. However, a pattern is not part of the definition, okay? A relation does not have to have a pattern in order to be a relation. A relation is simply a mapping of one set to another set, whether or not there's a pattern. Is there usually a pattern that we're interested in? Yes, but it does not have to have a pattern. Please don't forget, check out the practice set for this lesson. These are new concepts that will support future math study, and they are worth practicing. Like and subscribe if you found this lesson helpful, and please drop a comment or question to engage. I'll see you in the next one.